Let's look at graphing exponential functions from a list of ordered pairs. So if we were to have been given the pairs -2 and 1/9, 2, 9, 0, 1, and so forth, we would be able to graph a curve. Now, one thing that's kind of nice to know is when you're graphing a line, you need 2 points. When you're graphing a curve, you need at least 3. So even though in your homework or other examples there might be more points than this, I do want you to graph all of the points that are listed, but you only need 3 to generate a curve on your own. So let's go ahead and make a table with this information. So we have x and y values. Our first x value is a -2, and that matches up with a y value of 1/9. I'm going to put my x values in order, so the next x value I'll list is 0, and that has a y value of 1. And when x is a +2, y is 9. So we can go ahead and graph this information. Oops. Sorry, I thought I could move this around, but I guess that's a no. Okay, let's go ahead and graph what we have right here. Get a darker color. Okay, so when x is a -2, y is 1/9. So when x is -2, y is 1/9. So it's going to be just barely above the x-axis. Not even close, but you know what I'm shooting for there. Okay, when x is 0, y is 1. So when x is 0, y is 1. And when x is 2, y is 9. So when x is 2, y is 9. It's clear up there. And we'll just kind of sketch in that curve, and I totally missed that middle point. Let's try that again, shall we? Okay. So we have -2, 1/9, 0, 1, and 2, 9. Let's see if I can do a better job this time. Kind of. Okay, so there's our curve, and all you have to do at this point is to just plot the points, connect them into a curve, right? We're just trying to reinforce that idea that an exponential equation or function looks like a curve, not a line. We're so used to graphing lines, graphing lines, graphing lines. We've got to make sure we understand the difference a little bit right there. Okay? So let's take a look at another example of graphing a curve. And let's bring in, okay, so let's go another route. Let's graph f of x equals 1/3 to the x minus 5. And I'm going to give you a few domain values to plug in. And we've had a lot of practice with this kind of thing, so I want you to go ahead and pause this video and see if you can plug these values in on your own. We'll stick with the really easy values of -1, 0, and 1 for the domain. So go ahead and pause, work those through, find the range values, and then come back to me and let's match up our work. Okay, so if we have f of x equals 1/3 to the -1 minus 5, 1/3 to the negative 1 is 3. 3 minus 5 is a negative 2. So when x is negative 1, y is a negative 2. So let's do another one of these. If we have f of x equals 1/3 to the 0 minus 5, anything to the 0 power is 1. 1 minus 5 is a negative 4. So when x is 0, y is a negative 4. Last one of these. We have f of x equals 1/3 to the 1 minus 5. 1/3 to the 1 is just 1/3. So 1/3 minus 5 would be a negative 4 and 2/3. So when x is a negative 1, y is a negative 4 and 2/3. So let's go ahead and graph those points. When x is a negative 1, y is a negative 2. When x is 0, y is negative 4. And when x is 1, y is a negative 4 and 2/3. Oops, that should be a little lower. So the curve looks something like